Hello and welcome to this video on solving linear simultaneous equation. Now firstly, what do we mean by solving an equation? It just means in this case, where we've got one variable which is just x, solving it means to find the value of x. So in this particular case, we could solve it by getting x gradually on its own. So x has been multiplied by 3 and then you're adding 1. So do you remember that we undo the last thing that happened to the equation? So we could subtract 1 from both sides to get rid of that plus 1. So we subtract 1. And that gives us 3x just here because the minus 1 cancels out that plus 1. If we subtract 1 from here, we get 15. And then x has been multiplied by 3. So to undo the times by 3, we divide both sides by 3 and we get x equals to 5. So that's just a recap of solving linear equations. And it's linear, by the way, because we just have a mixture of x terms and constant terms. That's where we don't have the x. There's no x squared terms, for example. Now in this case we had one variable and there's one solution. But in this particular case, notice the difference here. We've got two equations at the same time that we're having to solve, and we've got two variables. We've got x and we've got y. So to solve these equations means to find the value of x and y at the same time, which satisfies both of these equations. Now can we do this one just by a bit of guesswork? We need two numbers that when we do x, when we add y, it gives us 11, but when we subtract y, we get 9. Now with a bit of guesswork, we might be able to work out that x is 10, because it's kind of halfway between 11 and 9 maybe. And then 10 plus what gives you 11 will be 1. And 10 minus 1 gives you 9. So in this particular case, solving it means to find the value of x and y, and we can see that this value of x and y satisfies both equations because 10 plus 1 is 11 and 10 minus 1 is 9. It works. So we're going to see a method to solve what we call simultaneous equations, when we have more than one equation at once and we've got two unknowns. So let's work on these questions here. X plus y is equal to 5, and we've got x minus y is equal to 1. Now the strategy for solving linear simultaneous equations is to try and make either the x's cancel or make the y's cancel by adding or subtracting the equations. Now if we call this equation 1 and this equation 2, let's see what happens if we were to add the two equations. So let's first try and add the two equations, so 1 plus 2. Well, if we add the left hand side, what is x plus x? Well, it gives us 2x. What happens if we add plus y and minus y? Well, they cancel, don't they? If you have 1y and you add negative 1y, 1 plus minus 1 is 0, so those actually cancel, so that disappears. And then if we add the right hand side, so we've got 5 plus 1 is 6. And what's great about this is now we've only got a single equation involving a single variable, in this case x, and it's much easier to solve. So in this case, x has been multiplied by 2, so we divide both sides by 2, and we find that x is 3. Now at this stage, if we know that x is 3, we can just substitute it back into one of the two equations, either 1 or 2, it doesn't make a difference, and that will allow us to find y. So if we use the first equation, for example, 3 plus what gives you 5. So if we write that down, in the first equation, I'm going to put an arrow of 1 to say that we're substituting to 1, 3, because x is 3, plus y is equal to 5. And then clearly we can see that y is 2, because 3 plus 2 would be 5. And there we go, we found the x and the y, which satisfies both of these equations. So we can check the second equation. If we do 3 minus 2, that indeed is 1. Now we could have also done it by subtracting the two equations. So if I subtract them, if I do 1 minus 2, let's see what happens. Well, if I do this minus this, x minus x, well that just disappears. X minus x is just 0, just like 10 minus 10 is 0. Now this is where it gets a bit harder. If we subtracted these, we've got y, and we're subtracting minus y. So it's y minus minus y, and remember when you subtract a negative, you end up adding. So it actually becomes y plus y, which is 2y. So when you subtract these, y minus minus y would be y plus y, which is 2y. And then if we subtract the right hand sides, making sure we're doing the first minus the second, 5 minus 1 is 4. And then we've got 2y is 4, so we just divide both sides by 2, so y is therefore 2, which we can see agrees with this other method. And then, as before, we substitute that back into one of the equations. So let's just choose the first one. If we sub it into 1, we've got x plus y, which is 2, is equal to 5, and what plus 2 is 5? Well, it's clearly 3, so x is 3. So you can see that in either case, we get the same solutions. X is 3 and y is 2. Now let's try another one. We've got 3x plus 2y is equal to 10. And we've got 5x plus 2y is equal to 18. Now you have a choice of getting rid of x or getting rid of y by either adding or subtracting the equations. So we've got to think, well, how do we make these y terms cancel? Should we add the equations or should we subtract the equations? Well, if you add the equations, you'd have 2y plus 2y, which is 4y. There's still a y there. That doesn't cancel, does it? But if you subtracted them, you'd have 2y minus 2y, and that then disappears, doesn't it? They then cancel. So if we label these again as 1 and 2, I find that helpful, but you don't have to write these numbers for the equations. Well, should we do the first equation minus second equation, or the second equation minus the first one? I think it's easier to do the second minus first, because 5x minus 3x, which is 2x, is easier than doing 3x minus 5x, where we end up with a negative number. So to avoid ending up with negative numbers, I would do the big X term minus the small x term. So we're going to do 2, and we're going to subtract 1. So let's be consistent. We've got that minus that, 5x minus 3x, which is 2x. 2y minus 2y, well, they cancel, that's great, so we got rid of the y's. And then we've got 18 minus 10, which is 8. And then divide both sides by 2, we get x is 4, so we've worked out that x is 4. And then we just substitute back into one of the equations. So if I substitute it back into the first one, we got 3 times x, which is 3 times 4, which is 12, plus 2y equals 10. Now it's just solving a linear equation. So y has been multiplied by 2, then you're adding 12. So you undo the last thing you did. So you're going to subtract 12 to get rid of the plus 12. So subtract 12. And that gives us just 2y now, because we got rid of the plus 12. And 10 minus 12 is minus 2. And then divide both sides by 2, y is minus 1. And we could check those values, x is 4 and y is minus 1, by putting it back into the other equation. Right, let's do a third one. We've now got, this is an Excel exam question, 5x minus 2y is equal to 33. And we've got 5x plus 8y is equal to 18. Now we could try and make the y's cancel, or we can notice that, look, the x terms are the same. So if the x terms are the same, we've got 5x and 5x, we know that either adding or subtracting them, one of those is going to make the x's cancel. Whereas with these, because they're different numbers, if we add them, we would have minus 2 plus 8, which is 6y. Or if we subtracted them, minus 2y, and we subtract 8y, would give us minus 10y. Either way, it doesn't make these cancel. But subtracting these is going to work, isn't it? So at this point, we think, well, if we number them, should we do that minus that or that minus that? Well, the 8y is bigger than the minus 2y, so we're going to do 2 minus 1. But it's not the end of the world if you subtract the other way around. So let's do this. That minus that, 5x minus 5x, disappears, it cancels, that's great. Then we've got 8y minus 2y. Do you remember when you subtract a negative, you add, so it's 8y plus 2y, which is 10y. And then we do 18 minus 33, which is minus 15. Then we're going to get a fractional value this time, so we divide both sides by 10. Minus 15 divided by 10 is minus 1.5. And then we just substitute it back into one of these two equations. Let's just put it back into the first one. So substitute into the first. We've got 5x, we don't know x yet. Now, you have to be careful here. We're doing minus 2 times minus 1.5. Well, that's going to be positive, isn't it? And 2 times 1.5 is 3, so it's plus 3. When we substitute in, and then equals 33. So we subtract 3 from both sides, we get 5x is equal to 30, and then we divide both sides by 5, we get x is equal to 6. Right, let's do some more questions. We've got 3x minus 2y equals minus 5, and we've got 2x minus 4y is equal to 2. Now this time the numbers on front of the x aren't the same, the 3 and 2 they aren't the same, and the numbers on front of the y aren't the same either. So we know that adding or subtracting the two equations is not going to make anything cancel. So what we have to do this time is we have to scale either one or both of the equations so that either the x terms are the same or the y terms are the same. So I'm just going to make the y terms the same. Now can you think of a way of either scaling one of minus 2 or minus 4 such that these would be the same number? Well, if you doubled minus 2, that would be minus 4, and then these would match. So what we're going to do is we're going to double both sides of the first equation. So I'm going to times both sides by 2. And I'm going to write these out again, these equations, both of them. So if we times this by 2, it'd then be 6x minus 4y equals, and don't forget to times this by 2, minus 10. And then if we just leave that alone, we get 2x minus 4y equals 2, but I'm just going to copy it out just so we have these equations together. And now this time, we can see that these are the same. So we've got something like we had before. So now we're going to decide, are we going to add or subtract them? Well, if we add these, if we had minus 4, and we added minus 4, then that would give you minus 8. That doesn't cancel, we need it to be 0. But if you subtracted them, if you did minus 4 and you subtract minus 4, that becomes minus 4 plus 4, which is 0, so they would cancel. So in general, if the signs are the same, if they're both plus or they're both minus, you should subtract. And are we going to do 1 minus 2 or 2 minus 1? Well, we should do 1 minus 2 because then we have 6x minus 2x. That's easier than if we do 2x minus 6x because we'd end up with a negative number. So we're going to do 1 minus 2. So we do 6x minus 2x is 4x. Minus 4y minus minus 4y is minus 4y plus 4y. We've already established that we're going to be 0 and they cancel. And then we've got minus 10 and we're subtracting 2 is minus 12. So then divide both sides by 4. We get x is minus 3. And then just substitute back into, say, the first equation. It doesn't really matter. So we've got 3x. 3 times minus 3 is minus 9. We've got minus 2y is equal to minus 5. This is quite a hard one, isn't it? Because we've got lots of negatives floating about. So we want to get the y on its own. So y has been multiplied by minus 2, and then we're subtracting 9. Let's add 9 to both sides, and hopefully make it simpler. So that gets rid of the minus 9 if we add 9. So we have minus 2y is minus 5 plus 9 is 4. And then we divide both sides by negative 2. 4 divided by negative 2, well, positive divided by negative is negative, so it's going to be minus 2. And then we've got our answer. So x is minus 3 and y is minus 4. All right, let's do another one. We've got 5x plus 3y is equal to 9. And we've got 7x minus 2y is equal to 25. Now, let's try and scale these again. But this time, if we scale the y, say, we're going to have to scale both of them because you can't times one of the numbers by something to get the other. You're going to have to scale both of them. So at this point, what you think of is the lowest common multiple of these two numbers. What's the lowest common multiple of 3 and 2? Well, it's 6. So we want to get both of these to be something involving 6y. So what do we have to times 3 by to get to 6? Well, 2. So if we double this first equation, I'm just going to put a times 2 there, so remind us. So we're going to times this by 2. We're going to get 10x plus 6y is equal to 9 times 2 is 18. Now what about the second equation? We need that to be 6y either plus or minus. We need to times that by 3. So we're going to times this by 3. It may help to write these on just to remind yourself what you're doing. So times that by 3, we get 21x. Times that by 3, we get minus 6y. Times that by 3, we get 75. And then we've got to think, are we going to add or subtract these equations? Now, if we add them, we've got 6y plus minus 6y. That ends up being 6y minus 6y, which will cancel. So if the signs are different, in general, you should add the two equations. So if we add them, 1 plus 2, that plus that, 10x plus 21x is 31x. That plus that just cancels. And 75 plus 18 is 93. And then conveniently, 93 divided exactly by 31. So we divide both sides by 31, we get 3. And then, as before, we substitute it back into either equation. I'm just going to substitute into the first. But actually, I'm going to sub into the original first one, not the scale one, because the numbers are smaller. So let's sub it in. We've got 5x. 5 times 3 is 15. Plus 3y, I don't know what y is yet. That's what I'm trying to work out, is equal to 9. But you could substitute into that one if you like. It doesn't make a difference. And then let's just solve it. So y has been multiplied by 3, then you're adding 15. So subtract 15 from both sides. You get 3y, 9 minus 15 is minus 6. Divide both sides by 3. We get minus 2. And then we're done. X is 3 and y is minus 2. Right, now we've got this applied question here, and I'll just read it. We've got the total cost of 3 adult and 1 child ticket is £30. The total cost of 1 adult and 3 child tickets is £22. What's the cost of an adult ticket and what is the cost of a child ticket? Now, if we just create variables for the cost of an adult ticket and a child ticket, then we can form some equations. So why do we let A be the cost of an adult ticket and C be the cost of a child ticket? So let's take our sentences. The total cost of 3 adult and 1 child ticket is £30. So what is the cost of 3 adult tickets? Well, the cost of 1 adult ticket is £A, and the cost of 3 adult would be 3A. So we're going to put 3A. Plus 1 child ticket, so plus C, if we make C the cost of child ticket, and that total cost is £30. So let's just say that this number is in pounds. Everything's in pounds. Then the second equation, the total cost of 1 adult, so 1 lot of A, we can just write A, and 3 child tickets, so 3C, is equal to £22. Now we've got some simultaneous equations that we can solve, and we just need to find the value of A, the cost of an adult ticket, and the value of C, the cost of a child ticket. So let's just try and make the Y values the same. What do we need to scale either one or both of these to make these the same? Well, if we times that by 3, the C by 3, then they would both be 3C. So let's times the top equation by 3, put times 3 times 3, that becomes 9A plus 3C, and 30 times 3 is 90, and I'm just going to copy the second equation, just for clarity. And then we decide, do we add or do we subtract the two equations? We're going to subtract, because 3C minus 3C, that would cancel. And we're going to do 1 minus 2, because then we have 9A minus A. 9A is bigger than A. So we're going to get 8A when we subtract, that minus that disappears, and that minus that is 68. And then we just have to divide both sides by 8. So the quick way to divide by 8, if you're doing it mentally, is to half, half, and half again. So half it is 34, half that is 17, and then half of that is £8.50. So the cost of an adult ticket is £8.50. Let's write that with a unit, £8.50. And then we need the cost of a child ticket now. So we can substitute it into either equation. Let's just substitute it into this one here, the first equation, but actually that first equation, not the scaled one. So we've got 3 times the cost of an adult ticket, which is £25.50, so just put 25.5, plus a child ticket, which we don't know yet, is £30. Now if we subtract 25.5 from both sides, we just get C is equal to 4.5, i.e. £4.50. So that is the cost of an adult, and that's the cost of a child ticket. And then we've got this more complicated example. Now this is actually an IGCSE further maths paper, but it could feasibly occur in a GCSE paper. And the reason why this is more difficult is that the equations aren't in the form that we're used to. So what are we going to do in this case? We don't like fractions and equations, so we're going to multiply both sides by y minus 2. So if we multiply the left-hand side by y minus 2, that gets rid of the divide by y minus 2. It cancels it out. So times that by y minus 2, we get that. And if we times the 3 by y minus 2, you could write 3 brackets y minus 2, but I just do it in one go. We've got 3 lots of y minus 2, which is 3y minus 6. And then if we just rearrange it a bit to kind of get the sort of usual form of the equation, like something x plus something y equals something, then why don't we say subtract 3y from both sides? We have x minus 3y. And to get rid of that minus 1, why don't we add 1? So minus 6 plus 1 is minus 5. And that looks a bit more what we're used to. Something x plus something y equals something. And let's just do the same with this equation. I'm going to multiply both sides by y minus 1, so we get x plus 6, because multiplying this fraction by y minus 1 just gets rid of the over y minus 1. And if we times the right-hand side, the 4 by y minus 1, we get 4y minus 4. And then I'm going to do the same thing. I'm going to subtract 4y, so we're going to have x minus 4y. And then I'm going to subtract 6 to get rid of that, which is going to be minus 10. So we've got these two equations here. That and that. Let's call these 1 and let's call that 2. Now the y terms aren't the same, but the x terms are the same. We've got 1x and 1x. So we should probably subtract the equations, because x minus x disappears. And what way around should we do? It doesn't really matter that much, but I'm going to do that minus that, because minus 3 is bigger than minus 4. So let's do 1 minus 2. x minus x disappears. Now be very careful here. Minus 3y minus minus 4y is minus 3y plus 4y is equal to just y. And if we do minus 5 minus minus 10, that's minus 5 plus 10, which is equal to 5. And then we just substitute back into one of these two equations. Let's just pick the first one. We've got x, which we don't know, minus 3 times 5, so that's minus 15, equals minus 5. If we just add 15 to both sides, then we get x is equal to 10. And we can check that with one of the original equations. If we do, say, the second one, x plus 6, so we do 10 plus 6 is 16 over 5 minus 1, so 16 over 4, which is indeed 4. And we can check it with the other one, but we're fairly confident at this point that we got it right. And finally, let's just do these test your understanding questions. And I want you to do these ones. So we've got 2x minus 5y equals 13. And we've got 6x plus 3y is equal to 3. And then the second test your understanding question I want you to do is 2y is equal to 3x plus 4. And 2x is equal to minus 3y minus 7. And again, this is not in the usual form, so maybe you could manipulate these equations to get it in this kind of form where we know what to do. So you may want to pause the video at this point to have a go at that. Right, let's do these. Now, neither the x terms are the same number or the y, so we're going to have to scale these. So it's up to you whether you make x or y the same. Let's just say make the y's the same. So 5 and 3, what do they both go into? What's the lowest common multiple? Well, it's 15. So to get 5 to be 15, we could times both sides of that by 3. And to get 3 to be 15, we can times both sides by 5. So let's do that to each equation. Now if we times both sides by 3 here, we get 6x minus 15y is equal to 39. And if we times both sides by 5 in the second equation, we get 30x plus 15y is equal to 15. Now, what we're going to do to the two equations at this point? Well, we should add them. They're different signs, and if we add these two, minus 15y plus 15y, they will cancel. So we're going to do that. We're just going to add them. 6x plus 30x is equal to 36x. That plus that just disappears. And 39 plus 15 is 54. And then we need to divide both sides by 36. Now, that's a bit harder. I think it's 1.5, but let's just check. Yes, it is. It's 1.5. And then we're going to substitute that back into either of these equations. Let's just say the first one. So, and we can sub it back either into the scaled one or the unscaled one. So I've got 2x, so 2 times 1.5 is 3, minus 5y is equal to 13. And then if we subtract the 3 from both sides, we get minus 5y is equal to 10, and divide both sides by minus 5, we get y is equal to minus 2. So well done if you got that right. And now this second one, which is harder, well that was pretty hard actually because we had a fractional value and we had a negative. Right, so I'm going to just rearrange this a bit first. We want to make sure that x and y are on the same side. So for this first one, I'm going to start with the 3x, and then I'm going to subtract 2y, so I have minus 2y. But I don't want the 4 on this side, so I'm going to minus 4, so it's going to be on the other side. So notice I've switched the sides of the equation. We could have also subtracted 3x. We'd have minus 3x plus 2y equals 4. It doesn't matter which way around we do it. And this one, I just need to add 3y to get rid of that minus 3y. So I could have 2x plus 3y is equal to, well, we've got minus 7 here. So now we have to scale both equations. These don't match, these don't match. So let's make the y's the same. We can make these both 6, couldn't we? 2 and 3, the lowest common multiple is 6. So I need to times the 2 by 3. And I need to times the 3 by 2. So I'm going to multiply both sides by 2. So let's scale that. If we times both sides by 3, we get 9x minus 6y is equal to minus 12. If we times both sides by 2, I get 4x plus 6y is equal to minus 14. Now, we add these, they're different signs, so we're going to add them. So we're going to make that 1, that 2, and we're going to do 1 plus 2. So if we add 9x and 4x, we get 13x. That plus that just disappears. And minus 12 plus minus 14 is minus 26. Now, conveniently, 13 goes into 26. You divide both sides by 13. Minus 26 divided by 13 is minus 2. And then let's just substitute into one of these original equations. In fact, we one these original ones at the very, very top. So if we sub into this one, we have 2y is equal to 3 times x, 3 times minus 2 is minus 6, plus 4. And that means that 2y is equal to minus 6 plus 4, which is minus 2, and then divide both sides by 2, y is minus 1. And you might want to check that by checking when you put x is minus 2 and y is minus 1 into both these original equations, it works. But well done if you got that right.